Welcome to solverfy.
This is the answer to Chapter 15, problem number 59 from the Smith Organic Chemistry textbook. And this problem says, when 3,3-dimethyl-1-butene is treated with HBr alone, the major product is 2-bromo-2,3-dimethylbutane. When the same alkene is treated with HBr and peroxide, the sole product is 1-bromo-3,3-dimethylbutane. Explain these results by referring to the mechanisms. Okay, so let's do that. So the molecule that we're talking about, 3,3-dimethyl-1-butene, looks like this. There we go. So 3,3-dimethyl-1-butene. And so when we treat this with HBr under non-radical conditions, the mechanism is going to be this. So the electrons of the double bond will grab this proton. The HBr bond breaks. And so we have this after the first step with a carbocation located here on this secondary carbon. And what's going to happen here is we will get a 1,2 methyl shift. So a 1,2 methyl shift to get this intermediate. And so now our carbocation is on a tertiary carbon. And so actually, I guess, not that it matters since the molecule is symmetrical, but it would be more correct to say that the carbocation is located here. Again, it doesn't matter, the molecule is symmetrical. And so now we have a tertiary carbocation. And so now the bromine ion, the bromide that we formed in our first step of this mechanism can come and attack and add there. And so we get to our product, which is this. Okay, so 2-bromo-2,3-dimethylbutane. Right, okay. So then when we look at the radical mechanism here, so same starting material, but now we're doing this under radical conditions. The radical conditions, the HBr and peroxide, are going to generate a bromine radical. And so it's going to be the bromine radical that actually adds first here. And that is going to look like this. So I probably should have drawn this oriented differently, but there are the arrows. And so after one step, we have this. And now the radical is here. So the radical is where the carbocation was after the first step in the above mechanism. But this radical is not going to rearrange. We can't do a 1,2 methyl shift with a radical. And so what happens now is we have our HBr, and we get that. And so here is our product. And we've also generated another bromine radical. Oops. So we've also generated another bromine radical that can keep this reaction going. Yeah, so there we go. That's the mechanistic difference here. Without the peroxide, we're going to form a secondary carbocation, which is going to rearrange to a tertiary carbocation. And in that case, the hydrogen is adding first, and then the bromine is attacking the tertiary carbocation that we rearrange to. However, when we do this reaction with peroxide, first we're generating the bromine radical, which is going to react. And then we have a secondary radical on our carbon there, and that's not going to rearrange. And then the hydrogen will add second to get us to this product, the 1-bromo-3,3 dimethylbutane, and generate another bromine radical to keep the reaction going. And so that's the mechanistic difference here, and that's why we get these two different products. And that's the answer to chapter 15, problem number 59.